And this is Mr. Santana, and in this video we're going to go over the exterior angle theorem, which says that the exterior angle, angle 4 over here, is equal to the two angles that are furthest away in the triangle. Now remember, angle 4 is adjacent to angle 3. Angle 3 is not the one that we use because it is touching angle 4. So it's the ones that are not touching angle 4 that add up to the one outside. Okay, so that's the exterior angle theorem, and we're going to use that fact to solve the examples now. So here's example 1. All right. In the diagram below, ray NQ goes through triangle MNO. What is the measure of QPO? So first and foremost, let's just go through this. This is ray NQ. This is what they're referring to in the problem. That's ray NQ. And we want to use this triangle MNO. That is what they're referring to there. Okay, so the one that we are looking for is this angle right here, angle QPO, and that would be this here, angle QPO. That is the angle we're looking for. Notice it is represented by 8x plus 6, and the angle adjacent to that, and let's change this color so you know what I'm talking about. This angle right here is adjacent to QPO. We do have the two that are furthest away from that in triangle P and O. So if we look at this triangle here, we can use the two furthest angles away from QPO in order to determine angle QPO. So the setup goes as follows. So it's going to be angle O, because it's not adjacent to angle QPO, plus angle O and P. That's this one right here, that's pointed at in the purple, is equal to the exterior angle QPO. And that's what we're looking for. That's the one that's highlighted at in the question over there. Okay, QPO. So angle Q is represented by 42 degrees. And we have to add that to angle ONP, which is this one over here in the purple. So that's 6x minus 6 degrees. Now that has to be equal to angle QPO, but QPO is represented by 8x plus 6 degrees. All right, so as it stands, we have what we need. And we're set. We can solve this. What we have to start doing is simplifying the part of the equation on the left side of the equal sign. So let's go ahead and specifically do this. Let's draw a pink line through here, and that will definitely separate the two sides of the equation that we are referring to. So on the left side, I need to bring like terms together. So 42 degrees and 6 degrees are like terms because they do not have an x. Those are called constants. So 42 and 6 are the constants we're going to bring together. 42 take away 6 ends up being 36. So this stays with us. Nothing happened to that. 6x plus, that's going to be a positive. 42 minus 6 leaves you with positive 36. So that's why we're adding it, because it's positive. And nothing happened on the right side of the equation. Notice this stays the same, 8x plus 6 degrees. Okay, we cannot cross the line until it's time to start using inverses. Now we're finally going to start using inverses. we need to bring like terms together using inverse operations first. So first and foremost, know that what we want is to get x on one side of the equation and to start isolating it, which means at the end of all this, we want this equation to say x equals a specific number. That is the goal. So I have x on two different sides here. I definitely want to bring them together. What I tend to tell you is to move the smaller x first, because that's going to leave you with a positive value if you don't like dealing with negatives. If not, then it doesn't matter. So 6x is being removed from that side, so I have to also keep it equal, and I have to remove it from this side. That's what's going to keep this equation equivalent. All right, so 6x minus 6x is 0, so we can cross that out. 0 plus 36 is 36 degrees. And then 8x minus 6x leaves me with 2x plus 6 degrees. Okay, so now I need to bring the constants together, and it does look more like an equation we're used to solving at this point. So this is take away 6 degrees. That is the inverse of plus 6. Remember, you have to do the same thing on both sides of the equal sign. All right, so 36 minus 6 is going to be 30 degrees. And that equals 2x, because 6 degrees minus 6 degrees is 0. 2x plus 0 is just 2x. So now 2x means 2 times x. So 30 equals a number times 2. So here, the inverse of that would be to divide by 2. And that's going to tell me what that missing number is. So 30 divided by 2 is 15 degrees. 2 divided by 2 is 1. 1 times x is x. So we can cross that out. We do not need to know or see that. All right, so we've arrived at what we need at this point. We've arrived at what we need. And let's actually take this. This is what we need. We needed x. Now that we know what x is, we can definitely put that in here and solve for angle QPO. So let's write that down. Angle QPO, which is what we've been looking for all along. And now we have the missing piece to be able to do so. We get this. So we know that x is 15 degrees, so it's 8 times 15. Sorry. Eight times 15 degrees is going to be 120. Plus 6 degrees. So my overall answer is 126 degrees. That's the measure of angle QPO. So we have solved this. That is my answer right there. Know that at this stage here, if you had just put this in the calculator, 8 times 15 plus 6, it would give you the final answer of 126. So you can do it that way, unless if you're asked to show all the steps, then you do what I just showed you. All right. So example number 2, slightly different here. Well, let's read it first. In the diagram below, ray FJ runs adjacent to triangle FGH. So it's a similar setup, which is important. And let's go over what that means. This exterior angle is here, it's provided, right? It's all this, right? So that's represented by 10x plus 6. And you have the furthest most angles. So let's use different colors here. This angle here, and for all intents and purposes, let's use green. So you have those two angles which are the furthest from the exterior angle, and we can go ahead and use the exterior angle theorem because we have the matches. All right, so as it stands, let's see, angle F plus angle G is going to be equal to angle JHG. We are specifically asked to find the measure of angle G. So let's keep that in mind. We're only going to focus on this once we figure out what X is, because we can figure out what X is here. All right, so angle F is the blue angle and is represented by 6x minus 3. And angle G is the green angle, and that's represented by 5x minus 3. And we have angle G, or GHJ, which is represented by 10x minus or plus 6. Very important to keep the signs the way they go. All right, so as I said before, and let's do the same thing. Let's split this using pink line. This is my equal line. Everything on the left has to equal everything on the right. So before I could do anything, all this on the left here has to be simplified. I can't just solve it as it is. I mean, you can, but it's going to require way more steps. So no need to do all of that. 6x and 5x are like terms. So 6 plus 5 is going to be 11x. Then minus 3, let's do a wavy line for that. Minus 3 are like terms because they are constants. So minus 3 becomes minus 6. And that is equal to 10x plus 6. Know that nothing happened on the right, so that's why it stays the same. Okay, now I can actually start bringing things together. As I said before, now we get to use inverse operations. We want to definitely use the inverse of addition and the right, because this is 10x plus 6 and 10 is smaller than 11. That's why I'm moving the 10. So minus 10 on both sides, well, 10x on both sides. That allows me to eliminate this 10x over there. 10x minus 10x is 0. 0 plus 6 is going to be 6 degrees. That's why that's left there. And then this becomes 1x, so I don't need to write the 1. So just x minus 6 degrees. So now all I have to do is use the inverse of subtraction, and I'm going to add 6 degrees on both sides. That is going to allow me to get x by itself, because it's the last step left in order to get this done. So here, negative 6 plus 6 is going to give me 0. That leaves me with x plus 0, which is just x. 6 plus 6 is 12 degrees. So we've just figured out what that is. Now, generally people tend to go back and use this angle to try and solve what we've been asked for, but we have to recall this is what we're looking for from the start. Angle G is what I circled in the question. So I need to use this expression, 5x minus 3. So angle G equals 5x minus 3. We know that x is 12, so this is going to be 5 times 12, and then minus 3. As I said before, at this point, you could type that into the calculator and you'll definitely get your answer. You'll get here 57 degrees, but I'll show you the steps when you are asked to show work. So 5 times 12 is going to be 60. Take away 3. And 60 take away 3 is indeed 57 degrees. So that is our final answer. Angle G is 57 degrees. We have solved this problem using the exterior angle theorem. Okay, hope that helped you out. There you go.